Welcome. In this lesson, we're going to talk about increasing function and decreasing functions. We know that the definition of function is that a function is a rule. Okay, we have discussed 8 function rules, 8 rules. That the rule that assign to each input in domain exactly one output in range, right? So this is the definition of function. We're getting more and more familiar with it, right? So each input from the domain, we get exactly one output in the range. We know the vertical line test, right? And we've discussed all of these 8 functions, And then we go about to discuss one-to-one function. And we know the definition of one-to-one function. And we also have talked about horizontal line test. And we also discussed what is the definition if it is not a one-to-one function. Oops. Okay, for it's not a one-to-one function. So one-to-one function, not a one-to-one function. And then if a function is a one-to-one function, we know that it has exactly one inverse. Okay, how many? Exactly one. We don't have more than one. Okay, so 175%. So this way you can see the font's better. So every one-to-one function has exactly one inverse. And we discussed the graph of the inverse, right? And we have also discussed the composition of a one-to-one function and its inverse. By the way, when we look at these operations, right, these compositions, the input here and the input here, they may not be the same. They may not be from the same place. This X is from the domain of F inverse because F inverse works on X first. And this other X is from the domain of F. The domain of the inverse, these two functions may not have the same domain and may not have the same range. But one's domain is the other's range. Okay, so number 3, the domain of F is the range of F inverse. Okay, and the domain of F inverse is the range of F. Okay, from our past example, this is not so very clear because in some examples we discussed, right? In some examples we discussed, such as the, like these two functions, their domain and range are the same, right? Their domain and range are always the same. So if you swap them, they're still the same. So we don't see that quite clearly, but here I'm just going to put that statement right here. So we will see that in the future, And today we want to discuss 2 other important concepts, which are increasing function and decreasing function. So what is the increasing function? A function f is increasing on an interval. So here it doesn't have to be the entire domain. If whenever input 1 is less than input 2, their respective output, the output for input 1 will be less than the output for input 2. Okay, for example, let's look at these functions that we just have studied, right? These 8 functions. Okay, so I'm gonna bring them with us. Okay, I'm gonna bring them with us. Increasing, decreasing, right? Increasing, decreasing. Which one of these is increasing? Which one of these is decreasing? Well, that's increasing, right? And the definition of decreasing, I'm going to put the definition of decreasing here too. Okay, which I already typed over here. I'm going to see some details. We're going to see some details, okay? So which one of these are increasing or decreasing? Or neither, or neither. For example, the first one, it doesn't matter what's the input. You know, when they're not the same, the output is always the same. So this first one is neither increasing nor decreasing. Neither increasing nor decreasing. So there are functions that are neither increasing or decreasing. How about this one? How about this one? If this, but what this neither increasing, decreasing is on the entire domain. Whenever we mention increasing, decreasing, we should be addressing the interval at which it is increasing or decreasing, right? For example, this one, right? So let's apply the definition. Let's apply the definition. There. Okay, I think we can just erase that. Okay, so look at this function. Okay, the definition of increasing or decreasing, right? When we look at the curve, it looks like it's increasing, right? How does the definition applies here? How does the definition of increasing applies here? Whenever the input, right? Whenever input 1 is less than input 2, arbitrarily. And it looks like we can consider the entire domain, which are all real numbers, right? So suppose I have x1 here and x2 there, right? They're out, what's their input? The input for x1, right here. Oops, I meant to use a different color. I'm gonna use green, right? So this is x1. And this heart is x2. And their output y2. Okay, the output is f of x2. And this output is f of x1. Right? So what are the input for x1? For x1, f of x1, right here. Right? We have 2 points here. We have 2 points here. What is x1? x1, okay, x1 is measured from the origin to here because that's the point, right? So that's x1. And what is x2? What is this x2? x2, I'm going to use blue. This much is x2. Which one is larger? Of course, x2 is larger, right? Because they're both negative numbers in this case. And f of x1, what is f of x1? F of x1 is this much. F of x2 is this much. Which one is larger? Okay, the shorter one is larger because they're both negative. They're both negative. That is true. Is that true for if I have x1 on this side, I have another x2 on the other side? Of course. So it is always true. It is always true. And therefore, it is an increasing function, right? Because the output is always the same as input. So whenever x1 is less than x2, their respective output is also true. So whenever x1 is less than x2, the output for x1 is the same as x1. The output for x2 is x2. Therefore, this is always true, right? All right. So let's look at another example. Let's look at another example. X raised to the power 3. This looks like an increasing function as well, right? This looks like an increasing function. Okay, so whenever, right? What's the definition of increasing function? Right here, right? There. Whenever x1 is less than x2, right? We have an x1 here, we have x2 here, you know, one is less than the other. X raised to the power 3, f of x1 is going to be what? It's going to be x1 to the power 3. And that is going to be x2 to the power 3. Right? So that is also true. So this is always true. All right? Okay, so now we know there's some increasing function. Do we have a decreasing function? Let's look at, this is the increasing function too. You can use the same narrative. How about this one? How about x squared? How about x squared? What do we say about x squared? Right? What do we say about x squared? Right? Overall, if you consider the entire domain, if we consider the entire domain, it looks like on this side is decreasing, on the other side is increasing, right? So overall, if you consider the entire domain is neither increasing nor decreasing on the domain, on the entire domain. Okay, it's neither increasing or decreasing because on this side is decreasing, on the other side is increasing. Now, how about we look at the left-hand side, right? When we look at the left-hand side, what's on the left, right? So I'm going to restrict from the interval from -infinity to 0. On this interval, the graph will be just like that. This is the graph. And this piece of graph is what? Is decreasing. Because whenever, right? Whenever x sub 1 is less than x sub 2, right? They're both negative, right? Because they're both negative, less than 0. And we square them. x1 squared is going to be larger than x2 squared. x2 squared. Right? For example, -2 is less than -1, right? But -2 squared is 4, -1 squared is 1. So -2 squared is larger than -1 squared. Okay, so on this side, it's decreasing. How about on the other side? So on interval, so the interval here, so it's decreasing on what? It's decreasing on this interval. Okay, decreasing on that interval. How about on the right side? How about on the right side, right? How about on the right side? Right? On the right side, I will remove, right? I'm going to just look at this picture. So the graph is from 0 to infinity. 0 to infinity. Of course, I can include the 0. I can include the 0, right? I can include the 0. So that's increasing, isn't it? Right? Whenever x1 is less than x2, and x2 squared will be larger than x1 squared. It's increasing on what? On that interval. Because whenever x1, x sub 1 is less than x sub 2, right? And they both need to be greater than or equal to 0 because it's in this interval. And you square them, right? And x1 squared is going to be less than x sub 2 squared. So we're quoting the definition, you see? We're quoting the definition. So in summary, right? In this case, right? If the entire interval is considered, right? If the entire interval is considered, right? This one, right? And let's see. And that one, right? And the whole of the interval. The whole of the interval. The whole of the interval. On these three intervals, right? On these intervals, insert a row, right? It's neither increasing nor decreasing because the interval in our consideration. How about the other one? It's decreasing on the set interval, right? Decreasing on the set interval. You can see whenever you say a function is increasing or decreasing, you have to indicate where it is increasing and where it's decreasing. And lastly, right? Lastly, this is increasing. But this increasing is on that interval. So we have to be specific about where. So now let's go back to see the definition of increasing and decreasing function. Right? We look at the definition of increasing, decreasing function. For input one is less than the other, this one has the same relationship, reversal relationship. Okay, so let's look at another one. Increasing, decreasing. This function apparently is increasing, right? This function apparently is increasing. Oh, how about this one? The absolute value function. The absolute value function, is it increasing or decreasing? It's very similar to the x squared function, right? On the whole of the domain, it's what? It's neither increasing nor decreasing. But on this half of the interval, right? From negative infinity to 0, or from 0 to infinity, one is decreasing, the other one is increasing. And the square root function is increasing. And how about this one? This one, when you speak the increasing and decreasing, you have to speak on separate interval, because overall is neither. Overall is neither. Yes, it's decreasing here, it's decreasing here, but if you choose a number from this side to the next side, you see you choose an x1 here, x2 there, and this side is always larger. You cannot say it's increasing, right? So it has to be for all of them. It has to be for all of them. You cannot just say, oh, for these is decreasing, but for all of these considered is neither. You cannot say that. They have to be consistent. So now, what will be the narrative for this guy? Okay, I want you guys to practice, right? Practice this. It's very similar. It's very similar. Okay, so once again, just like the other two, right? On the overall is neither. It's neither. Okay, so same function, the same function, same rule, depending on which interval you're considering, right? If you consider this interval, if the domain in our consideration is from negative infinity to 0 versus from 0 to infinity, right? From 0 to infinity, it is not, the increasing, decreasing tendency are going to be different. So on this from negative infinity to 0, your graph will only be up to here. That's your graph. Okay, if I include the 0, I could include the 0 if I wish, right? I can include the 0. And this is neither increasing nor decreasing. Oops. Okay, so this is neither increasing nor decreasing on this entire interval. But here it will be decreasing on what? On that interval. So when we describe increasing or decreasing, you must tell the reader where. Okay, so let's look at the other one. Let's look at the other one. On this interval, right? It's, if I only choose the positive side, that's from 0 to infinity. Okay, so that's increasing. Increasing on what? On this interval. Okay, so that's the narrative about these functions. And this other function is similar. This other function is similar, okay? I'm not going to repeat this, right? You have to separate less than 0, greater than 0, increasing, decrease. Both are decreasing though, by the way. Both are, on both intervals, they're decreasing. Oh, let me do it anyway. Okay, so both are decreasing, but you have to separate the interval. Okay, you have to separate the interval. So here, okay, let me insert 2 columns. And the same rule of the function, the rules are the same. The rules are the same. And we just have the, have the domain. We just make different functions, okay? The domain here is gonna be from negative infinity to 0, right? So the curve is going to be just half of it, just one piece, okay? And the other one is going to be just one piece as well, right? And domain and range, the range are all the same. The range are all the same. Domain or interval is specified differently. The intervals, and this other one is from 0 to infinity. 0 is not included in either case. In both cases, okay, this is neither increasing nor decreasing, okay? And this one is what? Decreasing on this interval. How about this one? This one is decreasing too, okay? This one is decreasing too, but we just have to separate them. It doesn't make sense to put them together. And last but not least, okay, I already mentioned it. This one is definitively an increasing function. So we have seen increasing function and decreasing function for our study. Okay, so the last one, we don't need to do any partition. This function is just what? Wait. Okay, I'm going to insert a row. And this is an increasing function. This is increasing. Okay. To summarize, oh gee, what am I doing here? Insert a row. Oh, there, that's why. All right, increasing. I want to put a summary before we close. Okay, I want to put a summary before we close. So all 8 functions we have talked about, right? We have talked about this function is increasing consistently, right? And this function, however, if you look at the entire domain, is neither increasing nor decreasing. So whenever we talk about increasing or decreasing, we have to specify where it is increasing or decreasing. So here it's decreasing on that interval, decreasing on the other interval, right? And that the definition has to be satisfied. And on these two, right, the absolute value function, neither decreasing, increasing. So neither decreasing, increasing, right? And some functions, they just increase everywhere, right? Such as the, x to the power 3 function, or the cubic root function we didn't do, and I'm sure you can't do that. And this function is consistently increasing on the entire domain. And of course, we need to specify, right? So it's increasing, you can say it's increasing on domain. You can certainly say that. Okay. So this is the topics of increasing and decreasing function concept. And thank you for watching. I will see you guys next time. Thank you for watching.